Seniors, shop teacher, chief here, late at night, continue our series of late night talks with the chief. We'll continue to drill down deeper into knowledge and base materials in stainless steel. No one is here at this point. Take my mask off. The COVID-19 is essential. Washing our hands, keeping our distance, wearing our mask, not just in school while you're out of school. So what I'd like to continue to talk about is we're in a pause moment, and that pause moment is about the pandemic, it is about our public health and our safety here at Assabet. So while we pause, we will be in a remote mode. We will continue to our curriculum, what we've been doing with TIG welding, obviously for stainless steel, which we've been doing, and then we will move on to pipe fabrication, pipe welding, and pipe fitting. So what I'd like to say at this point, seniors, we need to continue to learn about materials that we're about to weld and understand the chemistry and the alloying elements that are in the material so that we don't make mistakes. And if we do make mistakes, it's okay. It's a learning process. And the learning process is really understanding what the material is and the compatibility of the chemistry of your filler wire to your base material. Once you have that compatibility and you have that knowledge and that understanding that certain types of filler wire are compatible with certain base materials, then you can move forward into your proficiency of your welding of particular stainless steels. So I'd like to sort of talk about stainless steel and what happens to stainless steel when you weld it and how to keep it from changing the chemistry of stainless steel while you're welding. So we talked about in our previous series about stainless steel is about your speed, your heat input, the distance of your arc length to your base material, using pulse arc, using old-fashioned sort of way of welding with a Synchro wave. You can weld stainless steels with that. But before we drill down deeper into welding of stainless steels, can we discuss what is stainless steel? Well, we know that steel, which is magnetic, is iron and carbon. And we'll just keep that simple. So iron and carbon produces steel, which we have. We know that stainless steel is iron and carbon, but when they add 12% or greater of chromium, it makes it non-magnetic, or it makes it non-corrosive, if you will. So it makes it stainless steel. And that stainless steel can be a 308, 316, 316L. We'll talk about that in a minute. So that's an austenitic stainless steel. And that austenitic stainless steel is a type of series, right? A 300 series, which is referred to as an 18-8. 18% chromium, 8% nickel, non-magnetic, and it's an austenitic stainless steel. So it's the chromium content that makes it stainless steel. So with that said, not to be confused, stainless steel can be welded to steel. Yes, you can weld stainless steel to steel. You remove the oxide layer. Stainless steel has a passive oxide layer. It's self-healing, which allows it to be non-corrosive. Certain stainless steels, such as ferritic, martensitic, austenitic, and duplex, those stainless steels have different applications, have different chemistry. And that chemistry means the difference between higher temperatures, corrosive materials such as in piping and pharmaceutical and refineries. So those different types of stainless steels are used for different applications in power plants, in aircraft, and so forth. So stainless steel is a widely used material, but at our level, we are going to introduce you to the austenitic stainless steels. And that austenitic stainless steels are non-magnetic. They're 18-8. They have a higher chromium content, nickel content. They don't do well in highly corrosive environments or higher temperatures. So a 316L would do better in a more corrosive environment than a 304. So we know that we use 308 filler wire, 308 and 308L, 316 and 316L, keeping the carbon content at a lower level, keeping it not from overheating, keeping our temperature down, our speed fast, and our arc really tight is really the essence of stainless steel welding. So we know that we have to use a stainless steel wire brush. We know that at this point, when we're using filler wire, we know that we need to clean the filler wire. We know that we need to clip the ends of the filler wire. I'm using at this point a 1/16 filler wire. I'm using a 1/16 tungsten, and I've got a gas lens on this particular torch. We can go with non-gas lenses or with a gas lens. Most preferred in shops and industry, when you're welding piping, you will see a gas lens. So a gas lens allows you to have that even distribution, an envelope of gas without a turbulence happening. A gas lens is essential for reactive materials such as stainless and titanium, which reacts to the atmosphere. So with that said, I'll put my safety glasses on, get myself ready for some stainless steel welding. Using aluminum blocks as heat sinks. Whenever we try to weld stainless steel, it is preferred to have copper or aluminum heat sinks. Sometimes you can use a steel heat sink, okay? But you need, and it's preferred to use a heat sink when you're welding. It allows the heat to stay low. It allows you to move quicker. And it allows you to perform at a higher level. Keeping stainless steel clamped is essential. Stainless steel will have a distortion, if you will. A distortion is your nemesis in stainless steel. So keeping stainless steel fixturing, keeping it heat sinked, chill blocks, if you will, keeping it clamped down. And the rule of thumb is when you can touch that with your hand is when you release the clamps. So your stainless steel stays flat or stays perpendicular and doesn't move on you, okay? So with that said, put my welding helmet on, get my gloves on, late at night, got my filler wire. I'm in a non-pulse mode. I'm with what they call the old school pulse mode, is pulsing with your foot while you're welding. Here we go. Okay, seniors, so there's two approaches. If you're using a sinker wave, you don't have that luxury of having a pulse sort of application in your dynasty like we have here. So you can use the old-fashioned with your foot, you can pulse. You also have our dynasties, which has a pulse mode in there. So you can pulse by setting your parameters, and we will talk about that on our next phase of setting up the machine. Okay, seniors, it's getting late at night. Chief here, continuing with his Chief Talks, baseline knowledge, chemistry of the materials, understanding what happens during welding, what could go wrong, what could go right, and all these approaches at this point make for a better fabricator and a better welder. So upon leaving Assabet, you'll have a clear understanding of what is needed when you come across shops or job sites that have stainless steel applications in welding. Okay, seniors, good to talk to you. Good to see you, always. We'll keep on talking remotely for a short time, and then we'll come back together again. I promise you that. Okay, seniors. Chief, over and out, late at night here. Need to get going. Bye now.